Before we begin to create the create booking mutation, let's first create the utility function that will facilitate a Stripe charge. We'll need to have this capability to allow the person who's making the booking to pay the owner of the listing a set price before we can say the booking is finalized. The good news is we have a Stripe instance established in our lib API folder where we've already instantiated a Stripe client and a connect function where a user is able to connect their Stripe account with our Stripe Tiny House platform. We'll create another asynchronous function within this instance called charge. Let's take a quick look at the Stripe Connect API documentation to gather what we'll need to do to create a Stripe charge. We'll be sharing the link to this documentation in the lesson manuscript. The term charge constitutes having a user or someone pay something. There's many different types of charges that can be created, but we'll create a simple direct charge which is recommended for standard accounts, which are the account types that are connected with our Stripe Connect platform. In this context, the connected account, not our account, will be the ones responsible for Stripe fees, refunds, and chargebacks. We're looking at the Node.js example here for the Charges API, and essentially with the Stripe client available, we can create a direct charge with the create function available from the charges object within the Stripe client. The first argument of this function is a data object that is to contain information about the Stripe charge. There's many different fields we can specify here, with some being required. The first required value is the amount, which is the amount the connected user is going to be receiving, or in other words, the amount that we're going to charge the person making the payment. The second data value we'll provide is the currency, which is another required data option. This is to be a 3-letter ISO code to represent the currency. For our application, we'll be charging everyone with US dollars. Note that the amount refers to the smallest unit of the currency, so with the US dollars, the amount will be in cents. The third data value is the source, which is an optional data option, but it's useful since it represents the source being charged, like the ID of the credit card, debit card, bank information, etc. In our case, the value for this source will be passed in from the client. The last data value we'll provide, though optional, will be very important for us, and that is the application fee amount, which is a fee in cents that is to be applied as a charge and collected as the Stripe account owner, which is us. Now, as to how we're going to determine which Stripe account, connected account, is going to receive the payment, that will be the value we introduce in the second header options object for the field of Stripe account. This is where we'll provide the Stripe user ID we've collected when the user connects with their Stripe account and we've stored as the wallet ID field of the user document. Note that this is how we essentially have the person making the payment pay the owner of the listing. Remember, the person who's making the payment doesn't need to have a Stripe account. They just need to provide their payment information, and in our application, that will be their credit card or debit card details. Once the charge is made, Stripe will charge their payment information, and here, by applying or providing a Stripe account ID, we're essentially taking that charge and saying pay out to this Stripe account. We're the middleman. We simply are going to receive the amount or the fee for using the platform. We're going to set up our charge will be very similar to what's being shown here. So let's go back to our Stripe file and set it up. This charge function we have would accept a few arguments from the mutation resolver that we'll eventually establish. It would accept an amount of type number. It would accept a source of type string, which would further come from our React client app. And it would accept a Stripe account of type string, which is the value from the wallet ID field from the connected user document. We'll call the create function within the charges class of our Stripe client. For the data object, we'll pass the amount along. For the currency, we'll say USD since we want to charge everyone in US dollars. We'll also pass the source from the argument along as well. The application fee amount is the amount we want to charge the user to use our application, Tiny House. We can provide any value here up to the amount we're going to make the charge, but on the client, we're going to tell them that we're going to charge an extra 5% of whatever they're about to pay the owner of the listing. And though not very necessary, we'll say it'll be approximately 5%, and we'll use the math.round function to round the amount to the nearest integer. And in the options header object, we'll specify the Stripe account and pass the Stripe account value that will be passed into this function as an argument. From the response, we'll be able to look at the status field. This status of the payment will have one of three values: succeeded, pending, or failed. Since we're going to await for the completion of the asynchronous charge function, the status at this point should either be succeeded or failed. We'll do a check and say if the status of this charge response is not succeeded, we'll throw an error that says failed to create charge with Stripe. And we'll disable the camel case ESLint rule around our Stripe client charge function. With our Stripe charge capability established, let's begin to work on the create booking mutation. We'll first need to update the GraphQL type definitions for create booking. Just like our other mutations, we'll have this one expect an input of an object that we'll create shortly called create booking input. When this mutation gets resolved successfully, though we may not necessarily need this resolved information in the client, we'll follow the pattern we have and have the mutation return the primary entity that's either been mutated or created, which in this case would be a booking object itself. We'll create the create booking input object type. There's 4 required fields we'll want the client to pass in the input when the create booking mutation is triggered. We'll want to have the ID of the listing that is being booked, which will be of type GraphQL ID. We'll want a source, which is what the Stripe React component in our client will pass for us, and will provide details of the payment source being charged, like the ID of a credit or debit card. This will eventually get passed to our Stripe charge function we've just set up. We'll also want the check-in and check-out dates of the booking that's being made. When the dates get passed from our client to the server, we'll simply have them passed in as strings that are formatted as dates or look like dates. Notice that we're not passing in the amount that's going to be charged to the user. The reason being is we'll determine this amount from the check-in and check-out date values. By recognizing which listing is being booked from the ID being passed in, we'll gather the details of that listing, such as the price per day. We'll simply multiply the number of days the user is booking with that price. So if check-in is today and checkout is 2 days from now, including today, that will be 3 days. If the listing price is $100, that total amount will be $300, and we'll create that amount in our resolver function. Let's create TypeScript types for the input argument for this create booking mutation. We have a simple booking resolvers map we set up before, so we'll create a types file in the folder here to reference the types that pertain to this particular map. We'll export an interface called create booking args that will have an input field of type create booking input. And we'll create the create booking input interface that is to have the ID, source, check-in, and checkout fields. All of being type string. The ID field in our GraphQL API is of type GraphQL ID, but it gets serialized as a string in our TypeScript code. In our booking resolvers map file, we'll import the create booking args interface from the adjacent types file. And in our resolver function, we'll specify the input argument that is expected to be passed in. We'll also go ahead and say when the resolver function is resolved, it should return a promise of the booking object type. We'll also need access to the database and request objects from context, so we'll destruct them as well. We'll import the request interface from the Express library as well. We'll set up a try-catch statement, and in the try statement, we'll destruct all the fields from the input object: ID, source, check-in, and checkout. There's going to be a decent number of things we're going to be doing just in this mutation function alone. So before we build out the implementation, let's spend a little time talking about our game plan and jotting down what we want to do in comments. The first thing we'll do, similar to our other mutations, is we'll guard and specify that only a logged in user or a viewer should be making the request. Next, when we verify that the viewer has made the request, we'll try and find the listing document in our database for where the viewer wants to make the booking for. We'll specify an extra check here to say that if for some reason or another the viewer tries to book their own listing, we'll throw an error since we don't want users booking their own listings. Next, we'll do another safeguard. In the client, we've prevented the user or viewer from placing a booking where the check-in date is before the checkout date. This would be a pretty bad bug if ever to happen, so we'll also place a server-side check and say if the checkout date is before the check-in date, we'll throw an error. If the dates are valid, we'll look to create a new bookings index for the listing document to essentially update it with new dates. Remember how we mentioned before that we're going to use a bookings index object that's going to exist within every listing document that essentially is going to determine which dates the listing has been booked in. We'll need to update the listing document for where the booking is made, in which its booking index will now need to know the check-in and checkout dates for this booking. This is where we'll also check to see if the viewer has somehow tried to book dates that overlap existing already booked dates, and if so, we'll throw an error. We'll then get the total price we'll charge the person making the booking. We'll then look to gather the user document of who the host of the listing is. With the total price and the host information available, we'll then be able to create our Stripe charge on behalf of the host. And finally, with our actions now complete, we can look to update the various different documents in our database. We'll first need to insert a new booking in our bookings collection of the booking that's just been made. We'll then update the user document for the host to increment their income with the amount that was just paid to them. Then we'll need to gather the booking document for this newly created booking and update the bookings field of the tenant, the person making the booking. We'll also need to update the listing document that's been booked by introducing the newly created booking in its booking field. Remember, both the user document and the listing document in our collections has a bookings field to determine which bookings have been made for either this user or for this listing. And we'll then return the newly inserted booking. As you can see, there's a decent amount of work we're going to be doing just for this mutation. At least now we have a bit of a game plan, and we'll just fill in the work we want to do. So the very first thing we want to do is we want to verify a logged in user, or in other words, a viewer is making the request. We have an authorize function established for this, which checks to see if a user can be found based on the request details. So we'll import this authorize function from the libutils file. We'll run the authorize function, pass the database and request objects along, and check if the viewer from this function can't be found. We'll throw an error that says viewer cannot be found. Then we're going to see if we can find the listing document of the listing that's going to be booked. We'll use Mongo's find_one method to find the listing where the _ID field is the same as that from the ID field from the input argument. We'll wrap the ID from the input with the node Mongo driver new object ID class to have it in the format of a Mongo document object ID. And we'll import the object ID constructor from the MongoDB driver. We'll then check to see if this listing can be found. If not, we'll throw an error that says listing can't be found. We'll then handle the check to see if the listing host is the same as the ID of the viewer. So in other words, is the viewer booking a listing of their own? If this is to happen, we'll throw an error that says viewer can't book own listing. Now we'll look to see the dates the viewer has booked and see if we can check if the viewer has booked a check-in date that is after checkout or if checkout is before check-in. To help make this simple date comparison, we won't need to install and use a robust date library like Moment. Instead, we'll just use the date constructor function available in JavaScript to convert the check-in and checkout string values to their date representation. We'll then say if checkout date is before or less than the check-in date, we'll throw an error that says checkout date can't be before check-in date. At this point, we'll look to obtain a new bookings index object of the listing document with the new dates that the user or viewer has picked. This will take a few lines of code to achieve, so we'll try and consolidate this functionality to a function we'll call resolve bookings index, which will receive the bookings index of the listing document, the check-in date, and the check-out date in string values. We'll create this function in a second. For now, let's look to populate the rest of this mutation function. Now, with our bookings index to be prepared, we'll look to gather the total price of what the tenant will pay. This should be fairly straightforward. Here, we'll simply want to multiply the price of a listing document, which is for per day, with the number of days a booking is made. We don't have a library like Moment to help us, and though we could import it, we'll avoid doing so since we don't have a lot of work that deals with date objects on our server projects. We'll do our own somewhat rough implementation that should work for the vast majority of use cases. So we know that the total price will be equal to the listing price multiplied by the difference between the checkout and check-in dates. To determine the difference, we'll use the getTime function on the date objects, which gives us a time of milliseconds since the 1st of January 1980, which is the Unix epoch, and is an actual numeric value. We can subtract the millisecond time of checkout with check-in to get us the difference between the two times in milliseconds. With this difference available to us, we can divide it with the number of milliseconds in a day, which is 86,400,000, to get the difference in days. And now, if we checked in today and checked out tomorrow, the difference here will be 1. However, we always want to count the check-in days as part of the total price. So we'll add it by 1. And this should give us the total price for the booking made between the check-in and checkout times. For a few of the next couple of things we'll do, we'll need access to the user document of the host, the person who owns the listing. So we can use the find one method on the user's collection to find the document where the ID is equal to the host field in our listing document. We can then have a check for 2 things. If this host object doesn't exist, we'll throw an error. Additionally, we'll want this host connected with Stripe. That's the only way we'll be able to pay them out. This Stripe check is part of the wallet ID field of this host object. So if either the host doesn't exist or the wallet ID field doesn't exist, we'll throw an error that says the host either can't be found or is not connected with Stripe. And now, if all this information is available to us, we can create the Stripe charge. We'll import the Stripe instance object we've created in our lib API folder. And we'll run the charge function within our Stripe instance and pass in the payloads the function is to expect. The total price we want to charge, the source, which will come from the client and passed in as an argument to this resolver, and the Stripe user ID of the person that is to be paid out, which is the wallet ID of the host. At this moment, the charge would have been made successfully, and we'll simply need to now update the documents in the different collections. We have a bookings collection to keep track of all the bookings made in our app. We'll use the insert one function from Mongo to insert a new document to this collection. We'll add the values that we'll want. A new object ID for the underscore ID field, the underscore ID field for the listing to reference the listing that's being booked, the underscore ID field for the viewer, for the tenant to reference who's making the booking, and the check-in and check-out dates in normal string format. We'll need access to this newly inserted booking document. So similar to what we've done before when using the insert one function, we'll access the first item of the .ops property within the inserted results to get the newly inserted document. Next, we'll look to update the user document of the host and look to increment the income field by the total price. So we'll use the update one function from Mongo and update the user document where the underscore ID field is that of the host underscore ID. And we'll use the increment operator to increment the income by whatever the total price that's going to be paid out to this host is. Next, we'll update the user document of the viewer to specify that this booking now would be in the bookings field of this viewer or user document. So we'll use the update one method again in the user's collection, find the user document where the underscore ID field is that of the viewer, and we'll use the push operator to push a new entry to the bookings array field and add the newly inserted booking ID. Finally, we're going to update the listing document that's being booked. We'll use the update one method and find the listing document where its underscore ID field is that of the listing we've just found from the ID passed in as the argument. We could probably just use the ID passed in as an argument, but instead we'll be specific and say we want the underscore ID field of the found listing. We'll update 2 things in this document. We'll need to update the bookings index of this document with the new bookings index we've prepared. So here we'll use the set operator to update the entire value of this field with the new value we've prepared. And similar to the above, we'll want to update the bookings array in this document to have the ID of the newly created booking. We'll use the push operator and push the ID of the inserted booking to the bookings field. And that's all the changes we want done in this mutation resolver function. Now we'll simply have the function return the inserted booking document. And in our catch statement, we'll catch whatever error might have been thrown and place it within a new error statement that says failed to create a booking. Oof, it's quite a lot, but we're not done yet. We still need to build out the functionality for the resolve bookings index function that will create a new bookings index based on the check-in and checkout dates. We'll look to handle this in the next lesson.